Hello, St. John the Evangelist Algebra 1 students for the year 2020 through 2021. This is the first of three installments of some summer work, which I'm trying to put together in a productive way, an intelligent way, not to just have you do things for the sake of doing them, and not what we sometimes call busy work. I want the work to be purposeful. And so I thought I would begin with one of my favorite topics in mathematics that I think can have a real impact and can be related to an Algebra 1 course. This was one of the most famous and brilliant mathematicians who ever lived, Carl Friedrich Gauss. You can see that he was born during the early days of our nation, 1777, and lived until 1855, but he was not American, he was German. Gauss is considered by everyone to be a genius, even though he's not a household name. There are other mathematicians like that. Some of the mathematicians became household names did so because they also made important contributions to science, like Newton, for example. Newton was a mathematician. He, along with another German, not Gauss, but an earlier German, is credited with inventing calculus, Sir Isaac Newton, the one that we most think of for his laws of motion and gravitation. But he was a mathematician, of course. Math is the language of science. Gauss, not so much to my knowledge a scientist, but a brilliant mathematician. He is responsible for what is known as the fundamental theorem of algebra. And if it's called that, it's got to be pretty important. I'm not going to try to explain that now, but a little later in the course I will. Now, like with many historical figures, there is a legend about Carl Friedrich Gauss that takes place when he was a schoolboy. And it goes like this. The schoolmaster, as they called them back then, the teacher, apparently wanted a little time to himself. Maybe he had some papers to correct. Maybe he wasn't feeling well and just wanted to sit at his desk for a few minutes in peace. So he directed his students to take the natural numbers 1 plus 2 plus 3 plus 4 and sum all of them up to 100 to find the sum of the natural numbers from 1 to 100. And he thought that this would keep the class busy for a while. And with everybody else it did, except, as the legend goes, young Carl went up to the teacher, maybe it was with a slate, chalk on a slate perhaps back then, and he wrote down this without showing work. Nowadays, I don't know about Gauss's master at that point. He was no doubt amazed, and I don't even know, the story I don't think tells whether the master knew the answer. We teachers nowadays like our students to show work, because chances are you're not a genius like Gauss, although who knows. But he wrote down that number. How did he do it? How did he so quickly come up with the sum? And it was, the story goes, was in a few seconds that he gave the answer. And to explore this method gets into one of the, I think, most important aspects of studying algebra, the rest of high school math. And I've come up with a word for this. It's not standard in the literature, but I like to call it modeling. We make a model, a math model of what's going on. And, maybe more commonly, what I call a model is called a formula. So we're going to develop a formula, and it's going to parallel the method that Gauss used to come up with this answer. So let's start like this. First of all, I used the phrase the natural numbers. And the natural numbers, which are indicated by a stylized N like this, are simply 1, 2, 3, going on forever. And notice that they do not include 0 or negative integers. It's the positive integers, also known as the counting numbers. And of course, Gauss summed all the way up to 100. So let's try to indicate that. 1 plus 2 plus 3, dot, dot, dot. And let's just show plus 99, or actually 98. 98 plus 99 plus 100. And I'll leave out the ones between there with the 3 dots. What Gauss realized is, let's take a copy of that sum and reverse the order. So let's write 100 plus 99 plus 98, dot, 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 plus, and then this would be 3 plus 2 plus 1. Okay? Now, I want you to look at those two lists of numbers and add them term for term. What do you see? You should be able to look at it mentally. You could confirm it for all 6 if you like. All of the terms, including the ones in the middle that we left out, add up to what? 101. 101 plus 101 plus 101, dot, 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 plus 101 plus 101 plus 101. Now we have to ask the question, how many of those 101s are there? That's pretty easy, right? 1, 2, 3, all the way up to 100. There are 100 101s. So if we wanted to add, whoops, a little mistake here. That's a 101. If we wanted to add up 100 101s, what can we do? 100 times 101. 100 times 101. Is that the answer? No. To the original question. The original question is, what is the sum of the first 100 natural numbers? 1 plus 2 plus 3 all the way up to 100. Well, this sum, the 100 101s, is 2 of them, right? It's double the answer. It's double the sum of the numbers from 1 to 100 because we've got 2 copies added together. So what do we do now to finish out? Pretty easy, pretty obvious. We divide by 2. And that gives the answer that Gauss came up with, 5,050. You could cancel here, probably the quickest way. 100 divided by 2 is 50, and 50 times 101 is 5,050. So that's the famous story about young Gauss. Extremely famous. If you study anything about math, if you learn the name Gauss, that he was a big figure in the development of mathematics, this is probably the first thing you learn about him. All mathematicians love to tell this story. A large part of the study of mathematics is to be able to see things in general terms. And this continues with this idea that I'm trying to get you to see about modeling, or if you prefer, a formula. And we're going to develop a formula for the general case of what we just looked at in the story of young Gauss. The question is, to state it generally, what is the sum of the first n natural numbers, where n just represents as far as you want to go? In the case of the Gauss story, the n was 100. What was the sum of the first 100 natural numbers? We can ask, what is the sum of the first n natural numbers? We can go higher than 100. Anytime numbers get bigger, the math is a little harder, but we're not going to have to add up. If we wanted the sum of the first 1,000 natural numbers, 1 plus 2 plus 3, all the way up to 1,000, we'd use the same formula with, just the n would be 1,000 rather than 100. Let's look at a smaller n. to get a better handle on this. Let's look at 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Now, this one we can do the old-fashioned way. 3, 6, 10, 15, 21, 28. Okay? So the sum, this is the sum of the first 7 natural numbers. Here the n, the sum of the first n natural numbers. Here the n is 7. All right? Well, we'll do it the same way Gauss did. We'll create a copy of the sum and reverse it, putting 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And we will add them. In the Gauss story, each of the terms that are on top, one on top of the other, added to 101. Here they add to 8. So we have 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. And how many 8s are there? 7, which is the n. Okay? In the Gauss story, each pair here added to 100, and there were 100 of them because the n was 100. Here the n is 7. So we have 7 8s. So we will do 7 times 8. But of course, that's not the answer. That's double the answer because it's got the sum of the first 7 natural numbers, and it's got it again. It's got it twice there. So we divide by 2. And 7 times 8 is 56. Divided by 2 is 28. This is cool. Now, what's the general formula? I think I'll give you the general formula and then maybe look at one more example just to make sure after you see the formula you see, okay, this is as it needs to be. Okay. And again, the question is, what is the sum of the first n natural numbers? And here's the formula, or as I called it earlier, the model. We'll use a big S for sum. The sum of the first n naturals. The sum of the first n naturals. Here it is. It's n times n plus 1 divided by 2. Now think back to the 2 examples. Let's go through both of them. In the case of Gauss, the n was 100. He was asked to add the natural numbers up to 100. So here the n was 100, and the n plus 1 in that example was the 101, right? Every time you take the sum and then reverse the order and then add the 2 copies together in reverse order, the sum you get for all of those additions will always be 1 more than the n, right? So if you think about it, the 100, in Gauss's case, the 100 got matched up with the 1. So that ended up being 101, 1 more than 100. The 99 got matched up with the 2, 100 and 1 more than 100. In the case I just erased, the 7 was matched up with the 1, the 6 was matched up with the 2, so that they each added up to 8, which is 1 more than the 7. This n plus 1 is that the sum always being 1 more than the n. Okay? In the case of Gauss, it was 100 times 101 divided by 2. In the case of 7, it was 7 times 8 divided by 2. This is the formula. This is the model of how to add the first n natural numbers. And you can go as high as you want. N can be as high as you want, or as low as you want. Here's a very boring one. 1 plus 2 is 3. 2 plus 1 here, right? Add and get 3 plus 3. Well, there's 2 3's added together, so it's 2 times 3, but then you have to divide by 2 because you got 2 of them. 6 divided by 2, 3. Well, that's pretty boring. The Gauss one is cool. It really is. So, one more example, and then we'll move on to a related topic, which is actually in your textbook. It's in chapter 3, near the end of chapter 3. We'll go over it when we get to it. I'll assign some homework and quiz and test you on it when we get to it, as you'd expect. But I'd like to think that you're going to master it now, this next topic, which is related to the sum of the first n natural numbers. We can make connections between the two. But let's just take one more example. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Well, we'll go to 10. Okay? Now we could grind this out, and maybe you should do that just to confirm that the answer we get will be the same as going 1 plus 2. Well, we already know up to 7 is 28, right? So 35, 44, 54. I think that's right. We'll see if it is 54. So what do? Let's just go by the formula. The sum of these first n natural numbers is going to be n times n plus 1 divided by 2. Okay, this is the n, the 10. That's as high as we go. The n plus 1 is 11 here. Why 11? Because I won't show it all, but if we reverse the order like Gauss did, it would be 10 plus 9 plus 8, and so on. 11, 11, 11, and then all the way down here would be the 1, and they all add up to 11. And there are 10 of them. But we only want to consider one of them. We don't want the sum of 2 of them. We only want one of them, so we divide by 2. And, whoops. I said 54 earlier, didn't I? Well, it comes out to be 55. This is 28. Oh, I think this is where I went wrong. 28 up to here from before, plus 8 is 36, 45, 55. Yes. So I made a math mistake in my summer video, my first summer video to you. Oh well, we all make mistakes. Important thing is that try to fix them. You see something doesn't work out, you ask why, and that was an easy mistake to figure out. So the sum of the first n natural numbers, something you are responsible for. There will be a short, fairly short written assignment to go along with this video, and one of the things you'll have to do, I'll come up with some other examples. I will ask you to compute the sum of the first, 37 natural numbers, or 82, or maybe I'll go higher than 100, using the formula. I'll remind you of the formula on the written paper. All right, now we're going to move on to a related topic, which is in your textbook near the end of chapter 3. I see that we're at 18 minutes, so I think I'm going to break the first video that you get from me during the summer into 2 parts. I'll cover the related topic that's in our textbook in another video, which you should watch right after this one, or you can take a break, watch it the next day. You can pace out this work. And by the way, I didn't say this at the beginning, I don't think. My plan for this summer work is for there to be 3 sessions. Each time there'll be a video or 2. In this one there'll be 2. A video or 2 with some instruction, and then some papers that go along with that video that you should be able to complete. And this may vary, I'm not sure yet, depends on the topic, but I may ask you to submit it to me when it's done, or I may ask you to wait and submit to me the written work, the actual papers, when we are together. We'll see about that. This first installment, hopefully you're watching this around the end of June or early July. I plan the second one to be sometime in mid-July, and the third one to be in early August. And I'm trying to pick valuable, meaningful lessons for students of algebra. Take it seriously and enjoy the journey. This is the beginning of your journey along the path of high school math. The Algebra 1 course that I'll be teaching to you when we start up again in late August is a full high school math course. It's challenging. There's no doubt about that. You're going to have to work very hard, but I think I know that the effort is worth it. So please make an extra special, uh, you know, decide for yourself, make a commitment that your effort will be 100%. And let's get started on that now. These topics, again, it's not a throwaway kind of thing because it's summer and we'll just do something for the summer. No, I'm trying to create these to be important parts of your development as a high school math student. So have fun.